Hey guys, Jay here. Welcome back to the character development session. So in this video, we're going to focus on the movement aspect of the player. So I want you guys to first go through the scripting videos. Just make sure that you go through them multiple times, get those theories in your head and understand the basics of C# because this video assumes that you've gone through those videos. So make sure that you go through them and finish them off. So in this video, we're going to set up the character movement script and do the player control so we can actually walk around this area by the end of this video. And then we're going to tweak it in the next video and onwards. So make sure that you go through the scripting video if you ever run into any issues, or you can also reach out to the community and then ask any questions as well. Let's jump into it. All right, the first thing we're going to do is, as we did before, we're going to go to the scripts folder. When I say as we did before, I'm assuming you've gone through the scripting session. We're going to go to the scripting folder and then right click here, go to create, click on C# script. I'm going to call this third person controller. All right, let's call it third person controller. So this is going to be responsible for any and all kinds of movement when it comes to the player, right? So jumping, moving in multiple directions, rolling. I can't think of any other movements. So those are going to be the primary movements that the player is going to have. Apart from that, we're going to also come up with a separate script for maintaining player stats like health and ammo and things like that. That's for another video, but in this one, we're just going to focus on the movement only. So the first thing we're going to do is just open up this script, double click the script, and then that'll open up Visual Studio. So in Visual Studio, assuming you've already seen the previous video, I'm going to remove these comments. I'm going to get started by setting up some parameters for our third person controller. Now, obviously, your third person controller can have a certain speed for running. Now, this game, I'm not going to make it too complicated. I'm only going to have one speed where the player is always kind of jogging. It's not a sprint, but it's kind of a jog kind of movement. So Lara Croft, Tomb Raider has that. Uncharted has that. Last of Us, and some of these other games, Horizon Zero Dawn also has this, where the player is not walking by default. The player has a sort of a controlled jog where it's kind of fast. And then, you don't have really a walking kind of aspect to it. So I'm going to go with that same behavior in this game. So we're going to first start with having a variable. Now, I'm assuming you guys know what variables are. Variables are used to store data, right? So first variable we're going to have is a speed variable to control the speed of this character's movement. So let's get started by doing that. Now, speed is going to be measured in numbers, but it can also have decimal values. If you guys have gone through those sessions, you know that decimal values can be stored in float. So float speed. Okay, let's call it movement speed. All right, so I'm going to just give you the default value of 5, and we can always change that as well. Let's just Control S to save this. Always make sure to save your scripts or else it's not going to take effect. So let's just go to Unity and attach this script to the player. All right, so it always takes a couple of seconds to reload and compile your script as soon as you make a change, but that's fine. It's just a couple of seconds. And then, your script is ready to go. Now, where do we attach this script to the player? So just having the script created doesn't mean that it's now active. It's not active. You got to keep in mind that after you create a script, you got to attach it to a game object, right? You create a script, you attach it to a game object. That's when it becomes active. That's when all those things that you scripted comes to life, right? So far, we haven't done that. So let's do that. Obviously, this script will go to the player, right? So my player is called man03. I'm going to rename it as player, right? So we got a player over here. So we got to attach this script here. So there are two ways of doing it. The first way is you can click on the add component in the player and search for the script's name, which is third person controller, and it shows up. And if you hit enter, you have this thing there, just like this one. It's basically called a component. So a component is basically some sort of functionality that's attached to this particular game object, right? There's another way of doing it. So I'm going to right click and remove this. You don't have to do it, but I'm going to show you another way of attaching the script. Okay, the second way is while you have the player selected, you can drag and drop this script over here. It's the same thing, just two ways of doing it, right? You can do the same thing over here as well. You can drag and drop and attach it to the player. We've already done that, so I'm not going to do it. Cool. So I've created the component. But if you look at these other components that are already there in the player, you got these variables and things like that. But where is the speed variable that we just created? It's not showing up in Unity, right? And that's because if you go back to our code, this variable currently is private. Now, I mentioned this earlier that there are certain privacy levels in C#, right? Public, private, right? What this means is that it's either visible to the public, to the rest of Unity and all the other classes, or it's hidden. So if you don't explicitly mention public in front of a variable, it's considered private. That's why it didn't show up there, okay? So here's what we're gonna do. Just go in front of the float variable, just say public space float, movement speed, the rest is the same, right? Just put public in front of the variable. Now, as you can see, there are some changes pending. Hit save, go to Unity, and wait for it to reload. Now watch what happens over here. Boom. Now you can see movement speed as a variable, as a changeable property in the inspector of our player. And that's because it's public. So what that means is that when you set a variable as public, Unity can see that variable and make changes as well, which means now I can change the speed whenever I want, and it's going to take, and it's going to affect the player immediately when you run the game. Awesome. Now that that's done, let's go back to our code and do the rest of it. The next thing that we're going to do is we need a way to store the horizontal and vertical movements from your input. Now, for this game, I'm targeting PC as my target platform, computers, right? So Windows computers to be specific. So if you're targeting this for maybe, say, a PlayStation, the controls could be different, the input could be different. But Unity has a cool way of managing all of these inputs, right? So people could be using joysticks, people could be using, controllers and things like that, even while they're playing PC games, which means all of that should be supported. There is one common thing that you can use to support all of these devices, and these devices will be outputting the same movements basically when the player is moving the joystick or when pressing WASD keys or arrow keys, right? So basically what we're going to do now is store all that values that's coming out of the input hardware, whether it's the keyboard, joystick, controllers. We're going to store them as horizontal and vertical values. That's basically going to say, they're pressing the A and D keys or the horizontal values in the joysticks to move the player from left to right. That's the horizontal. Or if they're pressing W key or S key to go forward or backward, or joystick front and back to move the player forward and backward. That is vertical axis, right? Horizontal axis, vertical axis. Now we got to store those values. So let's do the same thing. Float horizontal to store the horizontal movements. Float vertical to store vertical movements. Now, I didn't make this public because these are values that are coming out of the input hardware, right? The actual physical hardware. But it's not something that we change in Unity. So I'm not going to make it public. You can if you want to, but if you're not going to make changes in Unity to these variables, it's just better to keep them as private, right? Another way to declare these as private, by the way, quick tip, is by saying private in front. But you don't have to do that because Unity assumes these variables are private if you don't explicitly put the word public in front. All right, moving forward. Now let's get these variables out of the hardware, whether it's the keyboard, controllers, or the joystick. Now, how do you do that? Do you do that in the start? That's not going to work. Why? Because start only runs for the first time that the game begins, right? Or this game object spawns. So we should do this in the update, because update runs every frame. That's the fastest method that we can access here. So we're going to use update to grab the input that's coming out of the keyboard and store them in the horizontal and vertical axis. All right. I'm really going in depth in explaining this simply because I want you guys to understand what exactly we're doing instead of just copying the code and pasting in your computer. I want you to understand so that when you actually build a game on your own, you know exactly how these things work. And that's what helped me when I was learning Unity the first time that I was trying this out. All right, let's jump into it. So all we got to do is say horizontal equals, we can say input.getAxisRow horizontal. Right. So, oops, I made a typo there. Right? And basically what this means is this horizontal variable will have the input coming out of the horizontal axis of either our keyboard or our controllers or our joystick, right? So we're going to use the word input to access the input library of Unity and say get axis row. Give me the row value that's coming out of these hardware for what axis? The horizontal axis, right? So we're going to do the same thing for vertical. Vertical equals input get axis row vertical. Now it's even better if I just rename this as horizontal input. That would make more sense. And when I do that, obviously Unity is going to throw an error because this doesn't exist anymore. So I'm going to use the same names here. And then there you go. We got the horizontal and vertical inputs coming through to your code now. Now we just got to do something with it. Now we know exactly that when the player is going horizontal or vertical. So when the player is pressing horizontal values, for example, in the context of keyboards, if they're pressing A key or D key, say they're pressing A only, you want to go to the left. Horizontal input is going to be minus values, pointing to the minus side, right? If they're pressing the D key to go to the right, it's going to be a positive value. It's on the right hand side, right? That's the easiest way to remember. Minus on the left, plus on the right, positive on the right. That's how you know if the player is trying to go to the left or the right, right? So if the player is not pressing any keys, it's going to be 0 on the horizontal, right? But say the player is pressing W key, vertical input is going to be a positive value going forward. If the player is pressing S key to go backward, vertical input is going to have a minus value. -2, -3 is a minus number, right? And if the player is not pressing it, 0. If the player is not pressing any of those, horizontal input is 0, vertical input is 0. I'm just running through some input examples, but we'll see this in action in just a bit. All right, that being said, now we got to go back to Unity and do one little thing. Now hit save. It's not going to do anything yet, but we're going to go back to Unity, right? We got to just do one quick thing. Let it compile. No issues. If there are any errors, they're going to show up in the console over here. You're going to see something in red, right? That's where you got to look into that line of code that it's throwing as an error, figure out what's wrong with it, right? In C#, most of the time, you're missing a semicolon, right? Or something else. All right. The first thing we're going to do now back in Unity is select the character, and we're going to add this specific component called a rigid body. Click on Add Component and say rigid body. Just rigid body, not rigid body 2D, just rigid body. Now, what is a rigid body? Rigid body in game engines is a way of bringing physics to games. Real world physics or simulated versions of the real world physics to games, right? Now, when you add the component rigid body to any game object in your scene, what we're actually doing is we're giving all the physics, simulated physics powers to that object, meaning we can do things like gravity, it'll have a mass, it'll have drag and all kinds of stuff that you can already see there. And we can have forces applied to them. So you might even see like in games, you know how like certain books or items fall to the ground, but if you just hit on them, they just start rolling, like real world simulated physics. That's rigid bodies, right? So we're making our character rigid body because it's a moving dynamic character that just goes around, right? And it affects other moving items as well. It can bump into other things like that. So we need physics. That's why we add the component rigid body to the player. Perfect. Let's go back to the code. All right, over here, now what we got to do is we got to figure out the direction the player is trying to go to. Player could be going to the front, maybe could be trying to go to the right-hand side. We don't know. Based on that direction, we're going to apply a force to this player to go to that direction. Does that make sense? It's like you're making a decision where to push a ball, to the right, to the left, or forward, or backward, whatever it is, right? Based on the direction you want to push this ball, you apply a force to that direction, right? That's exactly what we're trying to do through code. Player standing there. If the player wants to go forward, we push the player forward. If the player wants to go to the left, push the player left, right, back. That's what we're going to translate to code now. Super weird when I demonstrate it, but that's exactly the visual version of what we are about to write, okay? So first thing we got to do is we got to declare for the first time vector3. I would say it's move direction as the name of that variable. Okay, we declare a variable. Now, this is something new, right? Two things that I knew about this. First, the word vector3. Now, if you went through the scripting session, you know that vector3 stores three values, x, y, z, right? The coordinates of certain things in Unity space, right? The second thing that I did differently here is we are actually declaring a variable inside of a method, right? So, all right, if you thought that you only can declare variables at the top here, that's very wrong. You can actually declare variables inside of a method as well. The difference is variables that are declared over here are considered global variables. That's another keyword, global. What that means is that any variable that is declared at the top of the class is accessible by any method down there, right? That's the difference. See how we did that here? We declared this horizontal or vertical input over here, but we can also refer to them over here because it's already declared up there, right? But if it's not declared, see what happens. Don't do this, but the error pops up saying, I don't know what horizontal input means, because we haven't declared it. Declared it, error goes away, right? There's another way of doing it. You can declare a variable inside of a method. Now, what this means is that, can you access this variable over here and start? We can't. Why? Because it's only private to this method only. All right, that's what we're doing here. All right, back to this. So vector3 move direction. What we're going to do here is we're going to calculate the direction that the player is trying to head to. Okay, little bit of math involved, but if you think about it, it'll start making sense. And when you start actually practicing this over and over again, it'll make more sense, guys. So practice makes perfect. You got to start building a lot of games, a lot of mechanics for these to make sense. But get the idea in your head and try and copy the code. Look at my code and try and copy it and then try to understand it. But with practice, it's going to start making more sense. It's going to be very natural to you. All right. Vector3 move direction equals, what we're going to say is within brackets. Okay. Simply because we're going to do a bit of a math thing towards the end. But create brackets. Inside of that, we can say simply transform dot forward multiplied by vertical input. All right. When you're writing code, multiplication sign is actually done using an asterisk symbol, right? So what that means is we are multiplying this value from this value. So we already know what vertical input is. That's the input that's coming out of the keyboard's vertical input, but vertical axis. What's this? Transform.forward, right? Keep in mind that whenever you say transform, you're actually referring to yourself, right? Now, who's yourself? Whoever this game object is, who's holding the script, who is it? It's the player, right? Third person control is attached to the player. So transform in this context means the player, okay? Player.forward. It's quite simple if you think about it. It's English. It's literally English here. Transform.forward means the player's forward direction, which is if the player is turned this way, this direction. If the player is turned this way, it's this direction, this direction. Player.forward multiplied by vertical.input, right? So what that means in English is multiply the vertical input, which is where I'm trying to go to, by my forward direction. That's where I want to go to, right? Perfect. Other than that, we also want to say plus, do the same thing for the horizontals as well. So we're going to say transform.right, right, multiplied by horizontal input. So what that means is, guys, transform.right means just like forward, you're referring to the horizontal direction, either right or left, right? If it's left, you're going to get a minus value, like I mentioned earlier. So transform.right multiplied by horizontal axis that I'm trying to press to, whether it's A or D. Dot at the end, normalized. Right. So normalized means you sort of get a simpler version of this value instead of having a ton of decimals at the end, right? You're going to get a value that's more sort of rounded up and then, much more compressed and kind of easy to work with, or else you're going to get a very big decimal number here, right? So that's what dot normalized does. So this right here, this sentence is going to give us the direction the player is intending to go to. Perfect. What do we do next? We apply the force in that direction. That's what we do. Referring to my other code, it says rigidbody.add force. So that's what we're going to do now. We basically add a force in that direction that we're going to go to with the speed that's mentioned up here, which is movement speed. and the player is going to start traveling in that direction. It's going to be, that's pretty much it. We do that, the player is going to start moving. So let's do that. So how do we refer to the rigid body that we added as a component? We can declare it as a variable, guys. Here's what we're going to do. We're going to say public rigid body, and we can call it maybe RB for short, right? And we're going to control S to save this. Now let's go back to Unity to see what happens, because we made another public variable now, right? It's a rigid body. Let's go to Unity and have a look at this part here after it compiles. It's going to have another variable called RB. Now RB stands for rigid body. It says none, which means we haven't really dragged it yet. What do? We simply drag the rigid body here component to this slot. That means now that this rigid body is connected to this slot, meaning your script can now access everything that this component has to offer, all the physics stuff. Great. Let's go back here. Now we have an RB here. We're going to apply force to the rigid body component, because the rigid body is the guy who's handling all the physics, right? We're going to say rb.add force, and we are simply saying, now what we're going to do is we're going to say rigid body.add force in the direction that we want to go to, which is move direction multiplied by speed, movement speed. We're going to say force mode dot force mode dot force. What this does is, guys, it's just going to add a force in the direction that we have calculated here, multiplied by the move speed that we have defined up there, which is the actual character speed, and then we're going to add an effect of force. Now what that last part means is the type of force. You can have an impulse effect to it where it just bounces forward, or it can just be a simple force, which is what we're trying to do here. And that's it, guys. So hit save. Let's go to Unity and let's test this out. Let's see how it works. All right, hit run. And now if I press W, whoop, I can't even get there. Now, funny. Do you know what just happened there? Let's have a look at that. I'm glad it happened, actually, because it's going to happen to you as well. All right, let's have a look. Play's going through the flow, right? That happens because of a collider issue. Now, do we have a collider on this player? We don't, right? We don't have a collider on this player. Now, that's a big problem. We got to fix that. So what is a collider? Collider is basically like an invisible skin around the player or any game object in your game that allows it to collide with other game objects that has another collider, right? It's like skin. It's like the skin that we have. Right now, it's just a mesh on this player, which means there's no actual collisions on this mesh. We got to add some sort of collider to it to collide with other game objects. That's when it just collides, right? So that's what we need here. So click the player, go to add component. The best possible collider that matches this character's shape is a capsule, right? So for most characters, capsule collider always works. So search for capsule collider by, I went there, by the way, by using add component. Just search for capsule collider, and voila, you have a capsule collider here. But see how it doesn't cover the entire player? We're going to fix that now. So click on this icon over here that says edit collider. And that's going to give you tiny little dots around your capsule collider, if you can see, at this pivot point. If this is turned on, you can simply click on that and drag it to cover this player as much as you can. So just have a little bit of offset over here. Just make sure it covers the entire player and doesn't go beneath the player either. So click on this, where is that? This dot over here, and simply just make sure that your player is covered. So it doesn't have to be perfect at the feet level, just has to be kind of covering the player but above the ground, right? That's good. So the collider is kind of too thick, so we're going to reduce the radius here. So we're going to bring it down to maybe, something like that is actually pretty good. 0.25 is actually good, I think. There you go. That's pretty good. Awesome. So now if you run this, the player's not going to fall through the ground anymore. There we go. Awesome. Now can we move? Yes, we can, though. Well, that happens. All right. That happens. But we can definitely move, though. I'm moving from left to right, though. Why does that happen? Right? It's hilarious when physics bugs happen. It's happening because we have actually turned on rotation on the rigid body, meaning this player can actually topple over things. We got to stop that, right? The easiest way to do that would be in the rigid body component, go to constraints, and then freeze rotations X, Y, Z. All right. Now, if you run this again, you should not topple over when you try to move. Awesome. There we go. Now I'm using A key to move to the left, D key to the right, W forward, S to the back in its T-pose, right? So there we go. Now I can start exploring, kind of. But see, if you start running this, you'll notice that you can't actually turn the player. You're just going forward and backward and left and right. But the mouse direction doesn't really work yet, right? Because we haven't coded it. So even if you look that side and press W, it's still going to go to where it's facing. Ideally, it should go to the direction that the camera is facing, which we are going to work on next. This video is pretty long already. Make sure that you guys follow these to a T. This will work for you as well. And then rewatch it as many times as you need before you start the next lesson. I'll see you guys in the next video.